Hi everybody, this is Miss McClellan here to go over some background knowledge for IM2 Chapter 4 with you. We have two learning goals. The first one, I will be able to find the greatest common factor for a list of terms, and two, that you will be able to, so I will be able to, factor out the greatest common factor, this is often called GCF, from the terms of a polynomial expression and from an area model. We begin with some review from IM1. We're going to find the area, and we're not going to find the perimeter, so I'll change that in the notes, but we're going to find the area of these area models, and then we're going to write the area as a sum and as a product. Okay, first problem. We have x and x, so we multiply them. X times x equals x squared. We have x and we have 2. X times 2 equals 2x. We have another x and another 2, so we have 2 times x, and that equals 2x. And we have 2 times 2, which is 4. As a sum, we add all of these pieces up. So we have x squared, I circled these because they're like terms, plus 4x plus 4. And as a product, we just take the outsides. So this piece and this piece, x plus 2 times x plus 2. And you can write that as x plus 2 squared, since anything multiplied by itself can be expressed with an exponent of 2. Okay, next one. We have x times 2x, which is 2x squared. 10 times x, which is 10x. 3 times 2x, which is 6x. And 10 times 3, which is 30. As a sum, I have 2x squared plus, I'm going to combine these like terms, 16x plus 30. And as a product, I write 2x plus 10 times x plus 3. Next, I'm just going to write the results. So 5x times x is 5x squared. X times 2 is 2x. 5x times 5 is 25x. And 5 times 2 is 10. As a sum, we have 5x squared plus 27x plus 10. As a product, we have 5x plus 2 times x plus 5. And we continue. Now we're going to find the greatest common factor. What does the word common mean? In this context, common will mean that you have something in common. These numbers have something in common. So let's look. 2. We're going to list the factors of 2. The factors of 2 are 2 and 1. Let's list the factors of 4. The factors of 4 are 2, 1, and then also 4. The factors of 6 are 2, 3, 1, and 6. The greatest common factor in all of these is 2. That is the largest number that their factors have in common. This answer is 2. Let's do another one. I'll write this in a different format. 9. Factors of 9. 1 times 9 is 9. 3 times 3 is 9. Those are all the factors. 12. 1 times 12 is 12. 3 times 4 is 12. 2 times 6 is 12. I think that's it. 36. 3 times 12 is 36. 1 times 36 is 36. 4 times 9 is 36. 18 times 2 is 36. I could continue, but I don't need to. Oh, sorry, I should actually. 6 and 6. The greatest common factor can't be something that is not on every single list. So really all I had to check were the factors of 9. And 9 goes into 36 and 9, but it doesn't go into 12. The greatest common factor, the number that appears on each of these lists, is 3. Okay, let's look at these. 100. Okay. The factors of 100 are 25 and 4, 50 and 2, 5 and 20, 10 and 10. 1 and 100. The factors of 105 are 1 and 105, 5 and 21, 15 and 7, 35 and 3. I think that's it. And then I'm only going to check the numbers that these two have in common for 500. 500, 5 is a factor of 500. I don't care about 10 because 10 is not on both lists. I don't care about 3. I just care about 5. So 5 is the winner. Okay, continuing. 3x, 5x, and 7x. Now we have factors as well. 3x, the factors are 3 and x. 5x, the factors are 5 and x. I could also say 5 and 1, all that stuff, but 7, I should say 5 and 1. 5x and 1, 5 and 1. Anyway, and 7 and x. X is not necessarily the biggest thing because x could be a small number, but we consider quantities of x. In this case, x would be called the greatest common factor. Here, it's similar. The biggest x that each of these has in them is x squared. And we can also take out a 4 from each term. So the greatest common factor here is 4x squared. Here, I know the greatest common factor will include x cubed because that's the biggest exponent that goes into all 3 of these. Let's check for numbers. Let's see. 9 could be 3, 3, 9, and 1. 12 has a 3 in it, but not a 9 in it. 3 is going to be the biggest thing on each list. And the answer is 3x cubed. Okay, we continue. Now we're factoring things out of an area model. The biggest number that goes into each of these is 2. And x doesn't go into each of these. So I'm going to have 2 times what is 8x? Well, 2 times 4x is 8x. 2 times 8 is 16. And 2 times 3 is 6. What's the biggest thing that goes in all of these? Again, it's just 2. So 4x squared divided by 2 is 2x squared. 2x divided by 2 is just x. 6 divided by 2 is 3. Again, 9x squared. The biggest number that will go into all of these is 9, and the biggest exponent is x. Is going to be x squared, so 9x squared. 9x squared times x squared is 9x to the 4th. 2 times 9 is 18. X times x squared is x cubed. 4 times 9 is 36. And I don't need an x squared on that one. Okay, let's see. 2 is the biggest number that goes into all of these. And one of the terms doesn't have an exponent, so there will be no exponent right here. Okay, so we're going to have 5x squared, since 2 times 5x squared is 10x squared, 6x, and 3. Let's see. No numbers go into each of these, so it's just going to be an exponent. It's going to be x to the 7. So I've got x cubed up here, since x cubed times x to the 7 is x to the 10. I'll have x squared, and I need the 2, and I'll have 4 here. Again, here I have the number 4, x squared. This is going to be 3x cubed times, and this one's just x, and this one is 9. Okay, we continue. We're going to try to figure out how to factor these. And what I mean by factor is kind of what we did up here, but a little bit more. So I start with taking the biggest thing I can out of the top 2 boxes. For these 2 terms, the biggest thing that goes out of them is x. And then it's kind of like a puzzle. So I find these 2 pieces. X times x is x squared. X times 2 is 2x. And then I need to complete it with a 3 down here. Again, biggest thing that goes out of these 2 terms is x. Let's just do that for all of these. Biggest thing out of these 2 terms is x. Biggest thing out of these 2 terms is x. Biggest thing out of these 2 terms is, again, x. It's not always going to be x, but for these it is. X, haha, harder ones. Biggest thing that goes out of these 2 terms is 2x. Don't worry about the negative, you'll take care of it later. Biggest thing that goes out of these 2 terms is 3x. Biggest thing that goes out of these 2 terms, 7, I think. 7x, yeah. Okay. And then after that, everything can fall into place. I've done this x, I can do the top. X and 4, and then down here is 5. X and 6, and down here is 3. X and 1, and down here is 3. X and negative 10, and down here is 2. X and negative 4, and down here is negative 2. Okay, 11x, since 11 times 2 is 22. Negative 7, since negative 7 times 2 is negative 14. Negative 5, since negative 5 times 11 is negative 55. 4x, negative 7. What's 4 times 7? Yeah, that works. 7 times negative 4 gets you negative 28. 7 times 3 is 21. Negative 4 times negative 9 is 36. Okay, these are some challenge problems. We need to think about the relationships here. I need 2 numbers that add to 24 but work in the area model. What will that take? This challenge is left to the viewer. Try it, please. Thanks, everybody. That's the end of the notes. I hope you have a great day. Thanks for following along. Bye.